I'm going to talk to you about a very simple issue regarding doing correlation calculations on data and visualizing this with trend lines. Very often I see cases where somebody has naively plotted some data, computed the correlation typically with a spreadsheet, noticed that the correlation is high, and therefore assumes that that means that the data is connected in between the x and y in some causative fashion without understanding the nature of the data. And so we're going to look at the cases, 1 where the correlation is good for linear, and 3 where it is bad, to understand where the correlations can go wrong. This is known as, the 4 sets are known as Anscombe's quartet, and I'll be illustrating those as we move through the various cases. Our first case is for linear correlation that is good. We have the data here on the left, x and y. We can see x is simple linear case from 0 to 20, and y is trending upwards but with a large random component. If we chart a scatter plot, we can see that the data is somewhat scattered, but we can drive a linear trend line through that data, and the correlation we get is fairly high at 0.79. It's pretty good. And most importantly, when we look at the data, is that we can see the data is scattered randomly about the trend line. There's no clear bias in any way in terms of where the data resides. So this would be a good first approximation for a linear trend line and a possible causative correlation between the output y and the input values x. Now let's look at a case where this is not true. Now here we have a case where the same x values, but now the y values are in fact non-linear, and we can see that fairly clearly when we plot the scatter plot. We see that the y values curve up rapidly, starting below the linear trend line, rise above it, and then asymptote off below it again. So the trend line, which is linear through this, is clearly showing biases in the data points where they reside at the beginning of the line, middle of the line data, and at the end. So we could clearly see, if we were visualizing this, that what we would want is a non-linear trend line to fit the data. But in this case, a linear trend line, which is our first perhaps choice, looks actually very good. If we look at the actual correlation coefficient for the data, we see it's 0.97. That's remarkably good. And if we looked at that data, if we didn't look at that data, we would naively assume that this is a nice linear correlation. So it's important to eyeball the data and see if that is indeed the best fit. You could try different types of trend lines to see whether it fits better, but this is a case where the linear trend line looks good, but clearly is not the case, and that y is not linearly correlated with x. Now let's look at another case. Now here we see linear data. It looks very good. It looks like it's a straight line here, but with one outlier at the end here. This is pair value where x's value is 18 and y is 50, so well out of the range. Again, the correlation looks good, 0.85, and one would assume that this looks very good and is likely to be a causative fit. Now, one needs to look at this carefully. One is that you should look and see whether, again, the data is randomly scattered above and below the trend line. Clearly this is not the case. The values here are above the trend line, and then they transition to be mostly below the trend line here, because the trend line is being pulled upwards by this outlier. Now this is a good example where we need to look at the data again. If this is a true outlier and is just simply an experimental error, one could then remove it and replot the trend line, and then it might be a much better fit and look more like the case that we saw in our first scatter plot, with the data points scattered randomly above and below the trend line. But it's also possible that this what looks like an outlier is in fact a true experimental value, And if we redid the experiment again, we might see this reappearing and maybe some other data points in this area too. And that would indicate that a linear plot to the data is not explaining the data at all. There's no causation here. Something else is going on, because this is a true phenomenon and not some sort of experimental error in the data. So again, look out for this. The tendency for a lot of people is to assume that that is anomalous and remove it, but that may not necessarily be the case. It's important to check it. Our last case here, the x values are random, as are the y values, somewhere between 0 and 5, and between 5 and 10 for the x values. And then we have a pair of data at the end here where both values are 20. Again, if we chart the scatter plot, we see that most of the data is sitting in this area here, and here's our outlier. Now if we plot a correlation coefficient for that, again it looks pretty high, 0.83, which if we didn't see the data, we might accept that there is indeed good correlation, and therefore x may well be causing y. However, in this case, we need to be careful. Why is this outlier here? Is that this may be an experimental error? So what we need to do is remove this outlier and see if there's any of this data here retains this trend line. So here is the data replotted, but with the last pair removed. And as we can now see, the data is clearly very random, and there is no trend line here. It's effectively flat, and if we look at the correlation coefficient, it's effectively 0. So in this case, it's pretty clear that removing the outlier removes any connection between x and y data points, because they, in this case, as we know, they are in fact truly random. And so it's important to remove outliers in this particular case and understand this has nothing to do with the causative effects of x on y. So here I've tried to show some problems with correlation that I see very commonly in my work, and how to spot these problems and examine them further before one commits to thinking about simple linear correlations. If you want to learn more, please go to my course at Udemy. It's below, and you can take my course and learn more about how to do trendline analysis and data visualization. Thank you for listening.